All right. Good morning again. So for today, we will be discussing kinematic analysis of slopes. So, just a brief introduction. Discuss muna natin yung modes of failure in rocks. So, ano nga ba yung difference of the modes of failures sa rocks and soil? So, if you can remember, a few weeks ago, nag-discuss tayo ng circular failure, di ba? Tinignan natin kung ano yung, in-analyze natin yung circular failure and tinignan natin yung factor of safety. Yung circular failure, yun yung common type of failure when it comes to soil mass. Now, for rocks naman, iba siya since iba yung strength ng soil and rocks, diba? So, if you can also remember from the previous lessons, yung parang limit ng soil and rocks in terms of strength is 1 MPa. So, pag less than 1 MPa, that means soil siya. But pag more than naman, then maybe it can qualify as a rock na. So, ayun yung uniaxial compressive strength pala. So, yun. So we can say that hard rock is so much stronger than soil. So in fact, hard rock is usually so strong that failure under gravity alone is possible. Only pag may discontinuities tayo na nag-a-allow ng easy movement ng ating mga discrete blocks sa ating rocks, okay? So, alam na natin, di ba, na rocks are not usually homogeneous. That means we have discontinuities on our rocks. So, yung mga examples na nag-a-allow ng movement ay yung pag meron tayong foliated or bedded na rocks, meron tayong cuts ng joints, mga discontinuities natin, etc. Okay? So, ito yung mga modes of failure in rocks. So, meron tayong plane slide. So, parang nagsaslide yung isang block of rock in a plane. And then we also have wedge slide. Okay. And we also have toppling. Okay. So, dito na papasok yung ating kinematic model analysis. Kasi, when there are sets of discontinuities, we use kinematic analysis to anticipate or somehow predict the likely pattern of possible slope failure. So, i-discuss natin isa-isa yung modes of failures in hard rock. So, let's start with the plane slide. So, in order for a block of rock to slide along a plane, ito yung mga conditions niya. So, when a rock rests on an inclined weakness plane that daylights into free space. What do you mean by daylights? Parang hindi siya tago. Okay? So, like this one, no? Etong block na to, if you can see, galing siya talaga dito. So parang connected talaga siya dyan. But since this is a discontinuity, plane of weakness to, then pwede siyang mag-move pababa. Okay, pwede siyang mag-slide dito. This is because may free space sa baba niya. Okay? So if this space here is blocked, of course, wala siyang space to move. So, hindi siya mag-move. Okay? So, ayun. This only moves pag may free space ka. And the inclination of plane of slip must be greater than the friction angle of the plane. So, friction angle, this is a property of the rock, diba? So, pag yung inclination daw, or yung steepness ng plane na to, is greater than the friction angle of this rock, then that means pwede siyang mag-fail or pwede siyang mag-slide. Okay? So, yung conditions for failure na ito will reside dormantly on the slope. Okay? Like, kung meron kang structure and hindi mo pa siya ginagalaw, kahit na madami kang planes of weakness dyan, kung intact, like, kung yung rock ay hindi pa excavated, then wala pang space for the blocks to move, di ba? So, magkakaroon lang talaga siya ng instability or magfe-fail lang talaga siya kung gagalawin na natin yun. Kung may space na yung ating blocks to move. Okay? Kasi yung mga barriers, na rocks sa ating blocks, matatanggal siya kung i-remove din natin. So, that means pwede siyang mag-slide. And then next, we have wedge slide. So, for wedge slide naman, yung conditions for failure is when two planes of weakness intersect to define a tetrahedral block. So, this one, okay, tetrahedral block to, yung dalawang planes of weakness niya ay ito. First, ito, na nagdi-dip in this direction. Wait lang. Let me draw. Okay, so, ito yung unang plane of weakness. Okay? Nag-extend siya dyan. And then, nagdi-dip siya papunta dito. Alright? And the second plane of weakness naman is this one. Nag-extend siya dyan. Dipping in this direction. Okay? So, kung mag-intersect yung dalawang planes of weakness na yun, then makakabuo sila ng, di ba, the intersection of two planes is a line. So, makakabuo sila ng line na to. And, if mabubuo nila yung line na to, then, parang, pwede silang makabuo ng tetrahedral na pwedeng mag-slide pababa. Okay? And then, the second condition is when the line of intersection daylights into excavation. Okay, so, ayun, dapat wala ding barrier. Walang barrier na rock dito. Kasi kung may barrier dyan, hindi na makaka-move or hindi na makaka-slide pababa yung ating tetrahedral block. Okay? And then, dapat din, sliding downward siya. Kasi pag papunta naman doon sa kabilang side and then may intact pa naman to, may rock pa naman dyan, so hindi siya magsa-slide down. Okay? So that's the two conditions for failure of wedge slides. Okay, next is toppling. So for toppling, yung conditions for failure niya are these two. So the first one, it involves overturning of rock layers inclined steeply into the hillside. So yung ating rock layers, so as you can see here, parang siyang loaf of bread, no? So we have a block of rock. And then yung incline niya is steep, okay? As you can see, almost vertical na, okay? Nearly vertical na yung layers natin, okay? So that's the first condition. And then the second is that layers tend to bend downhill under its own weight. So if the layers are heavy enough na hindi na ma-support yung own weight ng katabi niya, then magbe-bend siya pababa. So yung first talaga, yung mga first few layers, yung unang magbe-bend. And then since wala nang magsusupport din sa weight nitong katabi niya, kahit upright pa yan dyan siya, since wala nang magsusupport kasi nag-bend na yung iba, then yung tendency din nito ay mag-bend din siya. And then sunod ng pasunod until nagkaroon na tayo ng toppling failure. Okay. Mention ko lang din na yung toppling failure, usually nangyayari ito kung paganyan yung ating rock. Kasi mas may tendency ito to bend, di ba? Yung mga maliliit. So, sa first few layers, pwedeng mas maliit siya kaysa sa next na layers. Okay? So, ito, mas may tendency talaga to bend. And then, magpa-follow na yung iba. Okay, so, that being said, let's discuss na kinematic analysis. So ano nga ba yung kinematics? Kinematics is the motion of bodies without reference to the forces that cause them to move. So dito mag-focus tayo on the directionality of our rock layers. Okay? So madaming rock cuts ang stable kahit na nasa slopes siya. Kahit din it contains steeply inclined planes of weaknesses. Kasi, and kahit din low yung strength ng rock. This happens kung walang freedom yung block of rock to move along that weak surface. Okay, so same lang na-mention ko kanina, 'di ba? Nagsislide lang kung merong or kung walang barrier. Okay? Kasi kung merong barrier, of course, may magsa-stop sa kanya to slide down. Okay? So kahit na low yung strength ng rock, kahit na sobrang steep ng incline niya, pwedeng hindi pa rin yan mag-move. So it is when we remove those blockage na may potential na siya to fail. Okay? So, yung analysis natin dito, using the kinematic analysis, will be focused on the directionality of this continuous rock to make sure that there is always a rock in the way or there's always a blockage para ma-prevent natin yung potential na failure blocks. Okay? So, hindi muna tayo mag-focus sa strength of rocks sa section na ito. Okay, so to do kinematic analysis, we must be familiar with these basic line elements in the rock mass. So we have the dip vector, normal vector, and intersection vector. So merong separate lecture detailing these elements and how to represent them on the stereographic projection. So you might want to review that then. So sige, review natin itong tatlong basic line elements na to. So, di ba, meron tayong strike and dip sa ating planes of weaknesses. So, yung strike and dip, may dalawa siyang elements doon. We have the strike vector and the dip vector. So, yung strike vector, ito yun. Okay, naglalay siya on the great circle, right? And then, this is the dip vector. The dip vector is pointed down the dip of a weakness plane. Okay? So, kung meron kang weakness plane, andito yung strike mo, yung dip mo ay pointed downwards sa weakness plane mo. Okay? Bearing at right angles to the strike and plunging with angle delta from the horizontal. Okay, so from the horizontal, angle niya from the horizontal is delta. Okay. And then we also have the normal vector. So the normal vector is pointed in the direction perpendicular to the plane of weakness. So kung ito yung plane of weakness natin, yung normal vector ay pointed naman towards it. Okay. And then let me change the color. So this is like perpendicular to the surface or to the plane of weakness. Okay. So to draw that normal vector in the stereographic projection, so galing ka sa dip, mag-move ka lang ng 90 degrees. Okay, until maka-reach ka na sa normal vector. Okay, that is also called the pole of your plane, right? And then lastly, we have the intersection vector. So the intersection vector, ito lang yung intersection of our planes of weaknesses. Planes of weakness. So ito yun. So for example, in this example kasi we have two planes of weakness. So we have 1 and 2. Tapos, to get the intersection vector, kukunin lang natin yung intersection ng dalawang great circles. Okay, so this is the first great circle. This is the second great circle. So yung intersection nila, yun yung intersection vector. Okay? Alternatively, pwede rin tong makuha kung kukunin natin yung line perpendicular to the great circle containing both yung normal vector ng planes 1 and 2. Okay? So, di ba, we have, sige, let's erase this muna. So we have here our first plane of weakness. So andito yung D1 niya or the dip vector. So mag-count ka ng 90 degrees, 'di ba? Mapupunta ka sa normal vector niyan. Okay? Yung isa naman from here, andito yung dip vector. Count ka ulit ng 90 para makapunta ka sa normal vector niya. Okay? And then, kung meron ka ng dalawang normal vectors, kunin mo yung great circle nila. Okay? So, gamit yung stereo net, kunin mo yung great circle. And then, from this great circle, kukunin mo yung normal to that. Okay? So, kukunin mo yung 90 degrees from that great circle. Okay? So, sa center ng great circle na to, magka-count ka ng 90 degrees. So, kung saan na point yon tutugma, then yun yung intersection vector of those two planes. Okay? So, yun yung dalawang ways on how to get the intersection vector of two planes. So once these are known, the dip vector, the normal vector, and the intersection vector, then we can do the kinematic analysis for rock slopes. All right, so let's go now to the kinematic test for plane failure. So again, ulit tayo dito, pero the requirements for sliding for plane failure, first is that there is no space to which the rock can move, and then dapat yung alpha or the angle of our cut is greater than delta. Okay, delta is the angle from horizontal of the plane of weakness. Okay, so ito. So the sliding requires that alpha is greater than delta and walang blockage here. Okay. Okay. So sa stereographic projection, how do we put these requirements sa stereographic projection? So if you have a stereographic projection, ang first natin gagawin is to draw the great circle of the cut slope. So ito yun. So yung cut slope natin ito, 'di ba? And this is a plane. So of course you can represent this in the stereographic projection. So this is our cut slope. Okay. And then the next step is to draw the dip lines. So assume tayo na may dalawang different dip angles. Okay. So let's say meron tayong delta 1 and delta 2. Ito yung angles for planes D1 and D2. Okay? Or for planes 1 and 2. Wait lang. Okay, so yung plane 1 natin is located here. And the dip vector of our plane 2 is located here. Okay? So ito yung corresponding nilang delta or the angle from the horizontal. So, using this one, pwede nating tingnan or pwede nating i-analyze kung anong planes yung pwedeng mag-fail and kung anong planes yung safe. Okay? So for this example, since yung dip 1 natin ay nasa part na to, kung saan mas maliit yung ating delta kaysa our alpha, then D1 allows sliding. Okay? And dito naman sa D2, since mas malaki yung ating delta kaysa sa alpha, then plane 2 hindi siya magsa-slide. Okay? So, etong shaded region na to, this allows sliding. And yung unshaded portion does not. Okay? So that's how we use kinematic test for plane failure. So let's go now to wedge failure. So for wedge failure, same lang naman yung procedures na ina-apply. Recall that the wedge failure happens when there is a set of, or there is an intersection of two sets of discontinuities, diba? So meron tayong dalawang discontinuities or planes of weaknesses. So this is the first one. And yung second one ay andyan. Right? So, meron siyang makakabuo ka ng line. And ito yung pwedeng mag-slide down. Okay? Okay, so parang madidetach yung tetrahedron natin sa main na rock. Okay? So, itong block of tetrahedron na to is magsa-slide down. Pwedeng mag-slide down. Right? So, how do we do or how do we project this sa ating stereographic net? Okay? So, example here is that we have tatlong joints daw. So, we have 3 sets of joints in this example. So, we have joint 1, joint 2, and joint 3. Okay? And given these 3 joints, gusto nating malaman if these joints could form a potential wedge failure. Okay, so how do we do that? So lagay lang natin siya sa stereo net, no? So the first thing that we need to do is we draw the plane of strike of the cut. So asan ba yung plane of strike of the cut? This one. Okay. Again, this is a representation of this cut. Okay. Okay. And then next is, titingnan natin ngayon yung normal to the joint sets. I-determine natin kung saan yung locations ng normal vector. Okay? Normal vectors of these 3 joint sets. So, alam naman natin how to get it. So, let's say, andito siya. Yung sa joint 1, nandito yung normal vector niya. Sa joint 2, this is the normal vector. And the joint 3, ito yung normal vector. Okay? So next is we determine the intersections by getting the great circles of the normal lines, then determining the perpendicular to it. Okay? So, di ba yung intersections, okay? Kukunin natin yung great circles ng normal lines. So, for example, kukunin natin yung intersection ng 1 and 2. So, kunin muna natin itong great circle of 1 and 2. So, yun. Oops. And then, for 1 and 2, yan yun. So, for 2 and 3, ito yun. Ay, sige. Ibang color na lang. Two and 3. And finally, 1 and 3. Oops. Okay. Tapos, since meron na tayong great circles ng containing the normal vectors, then we could get the intersection. Okay. So first, for 1 and 2, ito yung 90 degrees, diba, from that. So this is the intersection, 1 and 2. And then 2 and 3, 2 and 3 naman. So, 90 degrees from here. Ito yon. And then lastly, for 1 and 3, 90 degrees from the great circle. Oops. Dito siya. Okay. So, sige, let's erase muna kasi yun. So, after nating makuha yung intersections, we can analyze na which of the joints and combinations would be located less than the alpha. Okay, so saan ba yung mga locations na less than alpha? Ito yun, di ba? Kasi nandito yung ating strike of cut. Alright. So, ito, yung mga shaded regions, ito yung may potential to slide. So, ano ba yung nandito? The intersection of 1 and 2 and intersection of 1 and 3. Okay. So, yung joint set na pairs 1 and 2, ito, pwede tong mag-fail, mag-cause ng wedge failure. And then yung 1 and 3 also, pwedeng mag-cause ng wedge failure. So, yung combination ng 2 and 3, safe siya for wedge failure. Okay. Okay, so ganun lang. And then lastly, for toppling failure naman, so here for toppling failure, interlayer slips must occur before large flexural deformations can develop. Okay, so sliding will occur in this in this plane if this condition will be satisfied. Itong 90, oops, 90 minus delta plus phi sub j, it should be less than alpha. Okay. So, again, this alpha right here is the slope from the horizontal ng ating cut slope. Okay. And then, phi sub j is just the internal angle of friction. Tapos, delta, ito lang yung angle from the horizontal din of our layers. Okay. So usually naman these layers are parallel to each other, di ba? If isang set siya of discontinuities. So this delta should be the same lang all throughout. Okay. So again, sliding will occur if 90 minus delta plus phi is less than alpha. Okay. And how do we draw this in the stereo net? Okay, sige. Wait lang. May isa pa pala akong hindi nasabi. So, in toppling, it can only occur if the layers strike nearly parallel sa strike of the slope. Okay? So, dapat yung strike of the slope, ano siya, nearly parallel yung strike ng ating layers. Okay? So, parang yung top view niya, if this is our, okay, this is the strike of our slope, di ba? Cut slope. Let's say, ito yung parang ating face of the slope. Okay? Yung ating layers, yung strike ng ating layers ay dapat nearly parallel din with the strike of our cut slope. Or, pwede siyang mag-deviate naman, pero yung deviation niya is like 30 degrees, within 30 degrees sa angle nitong strike natin. Okay? Okay, so, ko lang. Okay, yung 30 degrees pala, it's not strictly 30 talaga, pero yun yung pina-follow na rule of thumb. Okay. So, sige, punta na tayo, balik tayo sa analysis. So, to analyze this, we need first to draw the cut slope of our great circle. the great circle of our cut slope. And ito yun. Okay? So, ito yung, ito. Right? And then next step is to draw small circles na 30 degrees away from the cut slope. So, ito yung representation na nung 30 na limit. Okay? So, the small circles are located here kasi 30 degrees siya from the cut slope. So, galing ka sa center of the cut slope, mag-ano ka lang ng 30 degrees pataas. Okay? So, i-follow mo yan na small circle. And then, mag-draw ka rin ng 30 degrees pababa. Alright. And then the next step is to draw the phi sub j or yung internal friction angle natin. Okay? So, balik tayo dito. Pwede kasi natin tong gawing 90 minus delta less than alpha minus phi, diba? Phi sub j. So, ito actually ginawa natin here. Minus natin yung phi from the cut slope or from the alpha. Okay. So, ito yon. To do this, galing ka lang sa cut slope, mag-move ka lang ng phi degrees. Okay? So, yan yun. And then, lastly, shade natin yung region with possible failure. So, again, base tayo dito. So, yung i-shade natin ay here. Okay? So, this region, pag dito, pag nandito yung ating plane of weakness, then dito parang may possibility to fail. Okay? So pag dito ka nagland, edi magfi-fail yung planes of weakness mo, na toppling yung failure. Okay? So again, yung steps, first gawin mo na yung great circle of the cut slope, and then gawin tong small circles na 30 degrees within the cut slope. And then gawa tayo ng great circle also ng phi galing sa cut slope, and then i-shade natin yung part na to. Okay, so that's for toppling failure. And then lastly, for due to self-weight. So, in case of sliding due to self-weight, failure can occur if yung surface natin dips steeper than the internal angle of friction or yung phi sub j natin. So, for wedge failure, any roughness of the planes of weakness adds considerable strength. So, in fact, it can often incline considerably steeper than the phi sub j without wedge failure. Okay, so to do the test here, so for sliding, ito yung gagawin natin, this one, and then for the toppling naman, ito. So for sliding, yung first natin gagawin is to draw a small circle of radius 90 minus phi, or yung ating internal angle of friction. So from the center, determine natin kung saan yung 90 minus phi. Okay? And then, using your compass, mag-draw ka ng small circle around it. Okay? Yung outside the circle, these areas here, contains all lines plunging na less than yung ating phi sub j, di ba? Thus, walang failure na mangyayari dito. Yung inside naman the circle, dito yung failure. Okay? Tapos, for toppling naman, mag-draw tayo ng small circle with radius phi sub j. Diba? So, phi sub j yung radius natin, and then centered siya sa center ng ating stereo net. Okay? So, mag-draw lang tayo ng small circle dyan. And then, yung inside the circle, these are the safe zones. And then outside the circle, unsafe. Okay. So, kinematic analysis can be done. Yung isa sa mga actual application of kinematic analysis is in an open pit mine. So, since we are excavating in different directions, di ba? So, lahat ng directions mapupuntahan natin kasi yung ating pit ay pa-circle usually. Okay? So, then there would be parts na more prone to a certain type of sliding than the others, depending on the direction of our discontinuities na present. So, if we perform the analysis on those different directions, we can actually notice na our pit will have different minimal or maximum safe slope angles, di ba? So, in this example, yung assumption natin dito is circular yung pit shape natin. Although usually hindi naman to, like, hindi to nangyayari na perfect circle talaga, no? Pero just for the sake of illustration, yung ginawa dito is from the north, from the actual north na direction, nag-move yung analysis 50 degrees clockwise or counterclockwise, and then until makabalik siya sa north. So, meron tayong 360 over 15 na number of analysis na ginawa. Okay? And then each of those parts, okay, ginawa natin ng sliding, plane sliding, wedge sliding, and then toppling na analysis. Okay? Tapos, tiningnan yung safe angles or minimal safe angles. And then, from that, tiningnan kung ano yung maximum na safe slope angle of that specific direction. Okay? So, ito yung parang tabular form of the data. So, we have here dalawang joint sets. So, joint 1 strikes daw at north 32 degrees east, and the other joint strikes north south. North south, yes. Paganyan. Tapos, we have here our dip vectors, and then we also have our intersection vector. Okay? So, lahat ng ano doon, so we have north, 15 east, etc. until bumalik sa, until na tapos niya yung full circle. Okay? So, parang different directions all throughout the circle with interval of 15 degrees. Okay? And then, in-analyze niya yung for sliding, for joint set 1, for sliding also ng joint set 2, and then for wedge sliding naman ito kasi intersection na siya. So, wedge sliding due to 1 and 2, and then toppling for 1, and then toppling for joint 2. Tapos, tiningnan natin dito kung ano yung angle sa lahat ng to, sa lahat ng analysis na ginawa per direction, per strike of cut direction. Tiningnan kung ano yung pinakamaliit na safe slope angle. Okay? And then, for example, dito sa north, meron tayong 90, 60, 61, 54, 90. So, ano yung pinakamaliit sa kanila? Eto, di ba? So, most likely, kung meron mang failure sa strike na to, na north, then most likely yung unang failure na mangyayari is the toppling on joint 1. Okay? So that's why yung applicable mode dito is toppling on joint 1. Tapos yung maximum na safe slope angle is 54. So hindi natin gustong bumaba sa 54 kasi kung bababa tayo sa 54, then magkaka-toppling failure na tayo. Okay? So, ganun din yung ginawa sa lahat ng strikes na to. So, tinignan kung ano yung pinakamaliit na safe slope angle. And then, that means yun yung likely na mangyari sa direction na yun. Yun yung likely na failure na mangyari sa direction ng cut na yun. Okay? And then, kung ano man yung safe slope angle doon, then that would be the maximum safe slope angle na. Okay, so that's, I mean, hindi tataas pala. Hindi tataas sa 54. So, yeah, so that's it for the kinematic test for an open pit mine or a circular excavation. Let's move on to the analysis of plane sliding using stereographic projection. Okay, so let's start with plane sliding, no? So according to the definition of an internal angle of friction, a block will remain at rest on a planar surface if the resultant of all forces acting on the block is inclined with the normal to the surface at less than phi sub j. Okay. Okay. So this is our block, and this is our plane, right? So the normal to our plane is this line. Okay? So sabi dito, this block will remain at rest kung hindi susobra sa phi sub j yung angle ng resultant vector. Okay? So, ito yung like parang condition for sliding. So, dapat mas maliit sa phi sub j, yung angle ng resultant from the normal para hindi siya mag-slide. Okay? Kasi pag so sobra na yan sa phi sub j, for example, nandito na yung resultant vector, then this block would slide na. Okay? So, para i-analyze natin yun, kailangan natin gawin yung steps na to. So, the first step that we will do is to plot the normal to the slope cut. Okay, so if we have a plane of weakness, then we have we have a slope cut. Yung normal doon, ipo-plot natin sa ating stereographic projection. So stereo net natin. Okay, so this is the normal to the slope cut. And then determine natin yung phi sub j. So ano ba yung phi sub j of the rock? Okay, and then magdodraw tayo ng small circle around n hat or the normal vector with radius phi sub j. Okay. So, gawa lang tayo ng small circle. And ito na yung parang friction angle natin. So, sa loob nito, kung yung resultant vector ng lahat ng forces na na-apply sa block is can be plotted inside the circle, then that means it's safe from failure or from sliding. Okay? Pag yung resultant naman plots outside this circle, this friction circle, then ito yung unsafe. Okay? Okay, so for wedge sliding naman, so for wedge sliding, ito yung susundin natin. So the first one is to plot the normal vectors n sub 1 hat and n sub 2 hat pointed out of the block into the supporting planes. So meron tayong, di ba sa wedge sliding, meron tayong dalawang joint sets talaga dyan. Okay, for a wedge sliding to occur. So we have here two normal vectors then, n sub 1 and n sub 2 hat. So i-plot natin yung normal vectors pointed out of the block into the supporting planes. So in some cases, one or both of these normal vectors will be in the upper hemisphere, in which cases two separate hemisphere tracings can be used. So, or the projection can be done on one tracing extending the region of projection outside the horizontal circle. So kung gusto yung tingnan yung details on how to do this, may guide si Goodman. Okay, so you can check that out. So paano ba to ginagawa sa stereo net, So we have two joints, right? And then the normal to those joints ay itong n sub 1 and n sub 2. Okay? Sub 1 and n sub 2. So yun yung first na ipa-plot mo. And then plot the line of intersection vector I sub 1, 2 hat pointed into the free space. So in some cases, I hat is directed into the upper hemisphere. So ito yun. The intersection of planes 1 and 2. Ito yun. These points. And then the next one is to trace the great circles common to n sub 1 hat and I sub 1, 2 hat and common to n sub 2 and I sub 1, 2 hat. So, okay, change ko lang yung color. This one. And this one. Okay. And then along n sub 1 hat, I sub 1, 2 hat, mark points P and Q at a distance phi from n sub 1, where phi is the friction angle for plane 1. So, galing daw dito, mag-draw tayo ng small circle, okay? With radius phi sub 1. So, parang ito. Ganito talaga yung first na drawing dyan. So, bale, phi sub 1, yung distance from the center. Okay, so this is phi sub 1 and this is also phi sub 1, papunta sa taas. Okay, so this is the first circle for the joint set 1. And then next naman, ganun rin, pero sa n sub 2 naman. So for n sub 2, kunin lang natin yung center and then the phi sub j ng 2. So yun. Then phi sub j rin ng 2 papunta sa kabila. So naka-create tayo ng circle na to. Okay. And then next, draw great circles through P hat and S hat and through Q hat and T hat. So ito yung nandito yung P hat natin, andito yung S hat natin. Gawa lang tayo ng great circle. Ayan. And then, sa kabila din, gawa ng great circle. Okay. And then, construct the friction angle of radius phi sub 1 about n sub 1 and phi sub 2 about n sub 2. Use only the portions of this friction angle shown in the next figure. So the remainders being kinematically inadmissible. So, yung final natin na figure here ay ito. Okay. So, yung inside this figure is safe for sliding. And then outside this figure is unsafe. Okay. So, yeah, so that's how we do the wedge sliding analysis sa StereoNet. Okay, so kung naguguluhan kayo, follow nyo lang yung instructions na to. And I think gagawin nyo rin naman ito sa lab.